up here and got it, right? All right, so when we're conducting a hypothesis test, we choose the significance level alpha, but we have little control over the value of beta. Common choices for alpha include 10%, 5%, and 1%. So why don't we make alpha very small to minimize the probability of a type 1 error? All right, so the first thing you need to know is that alpha and beta are inversely related. So what does it mean if they're inversely related? I feel like I skipped pages.
Alpha equals 1 over beta.
Okay, what was that, Morgan?
Or alpha's 1 over beta.
Okay, what is it? All right, that's right, yes. Alpha is 1 over beta, or beta is 1 over alpha. Hannah, what did you say?
As one gets bigger, the other gets smaller.
Very good. So as one value gets bigger, the other gets smaller. So if you try to make alpha as small as possible, then beta is just going to get bigger. So the smaller you make this is the probability of a type 1 error, this is the probability of a type 2 error. If you make this smaller, this gets bigger. Okay, if you make this bigger, this gets smaller. So you're never going to fully eliminate your errors. You're always going to have a probability of an error. But you just have to decide in your situation which is worse. What type of error is worse? All right, so I'm just going to draw a little picture here to try to illustrate the alpha and beta. I don't know if it'll make sense for you. Okay, so basically we've got basically the sampling distribution under the null. So this would be under the null hypothesis. And this would be the sampling distribution under the alternative hypothesis. Okay, so we could take each of the null and the alternative and their different sampling distributions. They're probably going to overlap somewhere. And basically we have our decision line right here. This would be our decision line. And everything below this we would fail to reject the null. Okay, so everything on this side, so these are values along here. Okay, these are values along the bottom. This is basically our z. So this would be 0 might be somewhere over here. Okay, so maybe 0 is somewhere over here. And so these are our negatives. -1, -2, 1. You know, maybe this is +2. Okay, 4. But this is our z on the bottom. So this is everything below. This is our decision line. Anything below here we're going to fail to reject, and anything up here we're going to reject the null. Okay, so if I reject the null, now rejecting the null, is it always an error if I reject the null? It's only a bad thing to reject the null when it's true, right? So this is the little section under here that represents the type 1 error. So this is the type 1 error right in here, and that's our alpha section. That's our alpha section. The probability that I make a type 1 error is right here. Remember, probabilities are areas under the curves, right? Areas under the curves. Now this over here, so everything over on this side of the graph is rejecting the null. So if I reject the null but it's actually true, that's a mistake. Okay? But I could also reject the null when I should have. If I reject the null when I should have, that's okay. That's a good thing. So that's this up here. This is called the power of a test. So this is reject the null when I should have. Okay, that's how I'm going to put it. Reject the null when I should have. Reject the null when it's false. If the null hypothesis is not true, I should reject it. Okay, good decision. This is a good decision. This is not a mistake. This is called power. This is called the power of a test, is this here. And the power of a test is 1 minus beta. All right, so now on this side of the curve, everything over here represents failing to reject the null. If I fail to reject the null when it's false, reject the null when it's false, that's a type 2 error. And that probability is beta. Now, up here, I failed to reject the null, but what if I fail to reject the null when it's true? Well, this isn't the power. This is just, the power of the test is rejecting the null when I should have. That's the power of a test, 1 minus beta. So, fail to reject the null when false, or when true, that's a good decision, okay? And this is 1 minus alpha. That's a good decision. It doesn't have a special name at all. It's just 1 minus alpha.
The extra one. Type 2, type 1 in power.
Yep, type 2, type 1 in power, and then just making a plain old good decision, okay? You fail to reject the null when it's true, okay? All right, so now the next set of notes is actually about power. So we'll talk more about power. This other little space we aren't going to worry about. It's kind of under the, we're not going to worry about that. Okay. I knew someone was going to ask about that. All right, so now in this statistics course, we will not be calculating power. If you choose to take more stats courses in college, especially if you're going into business or science, you may need to know about power of a test. And they do actually, you can calculate it, but we aren't required to calculate it. So you're just required to know what power of a test is, but not do the calculations. All right, so to choose an appropriate value for alpha, consider the consequences of making each type of error and choose the largest alpha value that is tolerable, okay? So in the judicial system, alpha should be low. If you're dealing with court cases, you want alpha to be really low because wouldn't you rather let a guilty person go free than an innocent person sit in jail? It is a lot more expensive if an innocent person goes to jail, yes.
But then more crime can happen. What if the innocent person has the ability? Yeah, it's hard.
Yeah, it's a hard decision, but I certainly wouldn't want someone who's innocent to be sitting in a jail cell somewhere. You know, someone sentenced to the death penalty when they were actually innocent. I mean, there's dangerous people walking around that'll never go to jail, you know, that'll never get caught doing things. So, okay, like Trevor. Yep, okay. So, now on the pregnancy test, you want beta to be low because it's more dangerous, especially for the baby, to be pregnant and not know it or think that you're not. Okay, so you don't want it to give you a false negative. So this time, in this case, a pregnancy test, you would want beta to be low. So it really depends on the situation. Some of you are always going with alpha level of 0.01 when you get a pick. You don't always want alpha to be low. Okay, you want alpha to be low. You want alpha to be low when you want the probability of a type 1 error to be low. Reject the null when it's true. So you choose a high value for alpha in the pregnancy test case. You choose a high value for alpha to make beta lower because they're inversely related. So other considerations for choosing alpha: extraordinary claims require extraordinary evidence. Smaller values of alpha should be used to test claims that don't have much other supporting evidence. So if you've got something that doesn't have a whole lot of evidence, choose like 0.0 or 0.01 for alpha. All right, so you've got 11 or 12 pages to read, and then you have homework on 2 different pages. It's not 2 different assignments, but we did cover a couple different chapters. We started talking about the errors and the 2-sided tests, which actually I already saw one of them in your homework already. So you have a little time to work, a lot of time to work. All right.